Welcome back. We're starting section 4-4 in your workbook, dilations. We're going to be looking at page 157, 158 in your workbook to fill that out. Instead of taking the straight notes, we're going to see if that's a little bit more helpful for people. Okay. A dilation, what does that mean? Well, everybody's been to the eye doctor, I hope, and they put those drops in your eyes to dilate your eyes, and what it does is it makes your pupils get really big. And for math, a dilation is pretty similar. It's just to make a shape bigger, or it can also make a shape smaller. So if this was your pupil, you put in some drops and it gets bigger. It's dilated. It made it bigger. But for math, you can also dilate something and make it smaller. So here's a square that gets shrunk down into a smaller square. Now the center of dilation, that is just the point that stays the same. So if I drew both of those circles on top of each other, that little dot in the center would remain the same when I went from the small to the big. Same thing for the square. If I put a little dot in the center of the square and I shrink the square down, that center of dilation stays in the same place. Now the third vocabulary that I want to make sure you are familiar with is the scale factor. And a scale factor is just how much bigger or smaller the shape got. Got bigger by 2 times, it's going to be 2 times bigger. If it got smaller by a half, the scale factor would be a half. All right, so let's see if we can apply some of this. So in your book, that gives you something that looks something like this. I know this looks a little bit, crazy, but if you just look at A, B, C, and D, those are 4 points, and I've given you the coordinates. Remember the coordinates in the XY system. So A is at point 0, 2, B is at point 2, 0, C is at point 0, -2, and D is at point -2, 0. Now I've also drawn 4 other points. This is A prime, B prime, C prime, and D prime. And in math, we often put this prime symbol on there when we want to say this is related, but it's a different point. So we went from A to A prime. Now, if you just look at this without even looking at the coordinates, A starts here at this point on the grid. And what do? I move it 2 places up. So I moved it twice as far from the center as it used to be. So right here, our origin is going to be our center of dilation. So I went from A to A prime. And when I did that, I just multiplied it by 2. I made it twice as far away. So I went from 2 spots away from 0 to 4 spots away from 0. Same thing for B prime. Instead of B being 2 places away from 0, B prime is now 4 places away from 0. And I did the same thing to C prime and to D prime. So what happened? Let's look at the coordinates now. A was 0, 2, and then I moved it twice as far away, and now A prime is 0, 4. See, I wrote 0, 4 up here. B was 2, 0, and when I moved it from B to B prime, then it became 4, 0. Same thing for C. I started C at 0, -2, moved it twice as far out, and then ended up at 0, -4. And D started at -2, 0, move it 2 times away, and it becomes -4, 0. What that means is that each of these points has been doubled. The scale factor for this dilation would be 2, meaning I have to multiply everything here by 2 to get to the new point. So this scale factor, we give the symbol K. That's why up here I wrote K equals 2. That's the scale factor is 2, going from A to A prime. So what happens if instead of doing a scale factor of 2, what if I want to do a scale factor of 1/2? Well, when it was a scale factor of 2, it went from 0, 2 to 0, 4. So a scale factor of 1/2 would go from 0, 2 to 0, 1. It's going to go in the opposite direction. So what do you think is going to go, 2, 0 is going to go to? 2, 0, when it was a scale factor of 2, went up to 4, 0. So when it's a scale factor of 1/2, it goes where? That's right. Hopefully you said 1, 0. All right. And so if it is a scale factor of 1/2 for 0, -2, you're going to end up at 0, -1. And if you go -2, 0, you're going to end up at -1, 0. So looking at these, Scale factor of 2, what happens? Scale factor of 1/2, what happens to these coordinates? What's that pattern? What is the pattern if I have my original point and then I have my dilation? Well, notice up here, what happened? 0 times 2 is 0. 2 times 2 is 4. 2 times 2 is 4. 0 times 2 is 0. Negative 2 times 2 is negative 4. 0 times 2 is 0. They did the same thing over here with a half. 0 times a half is going to be 0, but 2 times 1/2 is 1. So for every time I dilated, I followed this pattern. I took my original x and y, and the dilation point is going to be the scale factor k times whatever that x was, and then the y component is the scale factor k times whatever the y component was. And one thing you can notice is that if k is greater than 1, the picture gets bigger. If k is less than 1, that picture is going to get smaller. So here, if we connect these lines from A prime to B prime to C prime to D prime and back to A prime, you see that it went from a smaller square up to a bigger. If I connect the new points that I made from my scale factor 1/2, those points become down here. They shrink down. So it becomes smaller. So a smaller k value, smaller than 1, gives you a smaller shape. Larger than k1 gives you this larger shape. Larger than 1 gives you the larger shape. Okay. So you don't have to do that only with regular shapes. That was a square. On your next sheet, you have a shape that looks somewhat like this. All right, so what is this telling us? Well, it's telling us, I don't know how well you can see it, so I'll tell you. This point here is at 2, 2, okay? And it tells you that you have the dilation point is at 6, 6. Now, I went ahead and I drew it for you here. And I don't think they have that drawn in your book for you, so you're going to want to put that down. So the question is, what's the scale factor? Well, it's very easy to answer that. How can I get from 2, 2 and end up at 6, 6? What can I multiply to move it over? Well, every point gets the same k value. So what's the scale factor for here? Well, hopefully you can see that 2 times 3 is 6, and 2 times 3 is 6. So my scale factor here is going to be 3, meaning it gets 3 times bigger. And remember, every single point is going to get that same k value. So if I look at this point, which is 2, negative 1, if my scale factor is 3, then I have to do 2 times 3, and that'll be 6. And then I have to do negative 1 times 3, and that will be negative 3. So this guy here, when I draw him again, becomes 6, and then 1, 2, 3. 6, negative 3. And I can even connect that part of the shape. Now, what you need to do for the rest of this is pause the video, and for every point, and what I would do is I would just look at every point where the lines change. So every time that there's a corner, right, drawing those dots in for you, find the points of all those corners, just like this, and give it a scale factor of 3. So multiply it out to 3 so that you're drawing a bigger version of that shape. So pause the video and go ahead and take care of that.